Last are the drawbacks of NAT. Point number 1, poor number, pretty short, 16 bits only. That is also saying we could have only up to 60,000 simultaneous connections. If the local network there is for home use, this is plenty. But if the local network there is for enterprise use, if a company is there trying to save money and subscribing to only one real IP address, having lots of employees, lots of machines inside, chances high the packets going for one flow might be mistaken, okay, with the other flows. Point number 2. NAT is controversial. In the previous slides, you might see the authors of the textbook referring to these NAT devices as NAT routers. But routers are what? These devices in the core of the internet. Now, routers implement only 3 layers of protocol: physical, link layer, and network layer. So routers are also called the layer 3 protocols. Now, layer 3 protocol is supposedly only accessing layer 3 packet header. Layer 2 protocol accessing layer 2 packet header. NAT, if you think about the mechanism again, it's what? Replacing the IP address fields in the packet header. It's also replacing port number, okay, the port number fields in the packet header. IP address, that is a field in the, I know, layer 3 packet header. We learned about the IP packet format already. But port number, if you recall, in chapter 3, the transport layer, port numbers are there to differentiate different processes running on the host. It's actually a layer 4 notion. It's in the transport layer header, in the layer 4 header. So NAT as a router should not be doing that. So those who are against NAT boxes to address the network shortage, IP address shortage problem, okay, argue that we should probably, improve IPv4 such that we have more bits for the IP address field. So IPv6 is the next generation. It's using 128 bits for the IP address, much longer. We'll talk about this later. Point number 3, NAT box. Hosts sitting behind NAT box cannot be reached from a machine from outside. So that was actually presented as a benefit, a security benefit earlier, right? Hackers cannot be sending packets to 10.0.0.1 because that packet is just not going to go anywhere. Okay, not even reaching the NAT box in the middle, the IP address being 138 something. Right? Only packets with the destination address 138 something will be able to reach the NAT box. Okay? And NAT box there, it will also not know, right, what port number, what local IP address to convert back to reach 10.0.0.1. So, it's actually hard to reach local hosts from outside. So if packets are originated from outside, that's not going to work. Packets originated from inside, however, works. Now we know, right? So from 10.0.0.1, the box tracks the local IP address. Okay, keep it in a table. That packet gets translated using global IP, using real IP, goes out. Packet will come back to the router and the NAT box, look up the table and then translate back. So originated from inside, no problem. But data originated from outside, big problem. And this is a serious problem for these designers, P2P protocol designers. In P2P protocol, a lot of time we will try to establish connections between one user's host to another user's host. You and me being hosts, we are, chances high, sitting behind the NAT box, sitting behind the NAT router. So we'll have trouble calling directly to each other, setting connection directly to each other. If you recall in Skype's protocol design, making a call, the designer of Skype actually take extra step. Bob and Alice, we need to call a relay peer. And the relay peer will exchange packets for each other, okay, for these two peers, for Alice and Bob. So, application layer designer now need to worry, okay, in case layer 3 or layer 4 protocol is going to break. Okay, unexpected might happen. So, one layer's protocol designer needs to worry about another layer's, how it's designed, how it works. That's breaking the end-to-end argument. So by this here, okay, what I'm saying is this. The reference protocol stack there, okay, application, transport, network layer. So we say nice about, building the network protocols and separate them by layers so that it's modular. Designer in one layer does not need to care about what's inside another layer. Exactly the same thing we are arguing here. Application layer protocol needs to worry about another layer's protocol, how it works. So that breaks the modularity there we have in the original reference stack. And that is what end-to-end argument is referring to.